Hello viewers, welcome to Plant Ecology series. I am Dr. Snavar Soham from Kalindi College, Department of Botany, University of Delhi, and I was discussing the Edaphic Factor Soil. Now let's start with the structure of soil. What is the structure of soil? It refers to the arrangement or grouping of soil particles. This can occur as a continuum, single granule, say large or many aggregates or small parts. Soil particles are of different sizes. Gravel consists of small, loose rock particles larger than 2 mm in size. Now these are the largest particles in the soil. Then there are sand particles which range in the size from 0.05 to 2 millimeters. There are also silt particles in the soil which range from 0.002 to 0.05 millimeters, and then the clay, the finest particles which are less than 0.002 millimeters in size. Now sand and silt are the inactive or inert part of the soil matrix. They do not retain soil water or nutrients. Why? Because clay is the active portion of the soil matrix. The large amount of surface area per unit mass of clay and surface charge attracts the ions and water, whereas the negatively charged clay particles attract the positive ions, that is the cations, and release them to the soil water. So which is the most active portion? Clay, because it is able to absorb the negative as well as the positive charges based on its own composition, which are useful for the plant growth. Now cations such as potassium, calcium, magnesium, iron and zinc are the essential plant nutrients held by the soil particles, and they play an important role in plant growth and development. Now moving on to understanding of soil texture. Now what is the soil texture? This property of soil is based on soil particles. Now a soil texture includes the percentage of sand, silt and clay. So in what amount or in which percentage sand, silt and clay is present in a soil defines its soil texture. Now soil texture varies according to these three. The proportion of sand, silt and clay always adds up to 100% for all mineral soils. Now texture depends upon the plant material and soil forming process as well. Now a strongly developed structure possesses heavy texture. Depending upon the percentage of sand, silt and clay, soil texture has been divided into various classes, and it has been organized into a textural triangle. A soil containing 50% clay, 20% silt and 65% sand is called sandy loam, and a soil containing equal proportions of sand, silt and clay is called clay loams. So based on the composition of these three, the type of soil also varies. Now till now 12 soil textures have been reported. Now soil texture is important in determining first the nutrient holding, the water holding capacity, water movement and movement of soil air. So the texture influences all in all the permeability, which generally decreases with the decreasing particle size. Now this basically is a table which I had already discussed, and I told you about the particle size of different soil components. In this you can see that the clay soil type has the particle size which is less than 0.002 millimeters. It's finest, it's very fine soil. Now if we move on to gravel, you will see it is very coarse, very thick soil particles are present, which vary in range of 4.75 to 7.5 millimeters particle size, and silt and sand, they are in between clay and gravel. Now this is soil texture triangle which I just discussed about. you will see that this triangle helps in understanding of what type of soil is it. And you can see on one side is the percentage clay, on the other side is percentage silt, and on third side of the angle, the third side, there is percentage sand. So varying upon the more amount of clay and silt is present, it forms clay loam, and depending upon the percentage of these three, we have 12 types of soils which have been basically classified. Now the soil particles get grouped to form aggregates with pore spaces in between. Soils have also been divided into different grades and classes. What are these? If we talk of class, let's understand what a class is. It describes the average size of individual aggregates. Now classes are of different types, such as very fine, which is thin, medium, coarse, which is thick, and very coarse, which is very thick in nature. So depending upon that, we basically divide the soil into different classes. Then second way is of basically representing or understanding the soil composition is grade. Now it represents the degree of aggregation, how much it is aggregated. It is based on the properties of cohesion and adhesion between soil particles or aggregates. Now the soil have been graded in the range of 0 to 3. Now if no aggregation is there, that is no definite orderly arrangement of particles is there, it is less structured. Now poor aggregation between the particles is there, then the soil is referred to as disturbed. So these are the various categories where based on aggregation we define that is it structureless soil or it is poor aggregated soil. Then the third type is well formed distinct aggregates. Now in such cases a mixture of full aggregates, broken aggregates and some non-aggregated material is found. And the fourth category is the strong durable aggregates. Very large aggregates and little or no non-aggregated material is found in such soils. Different types of structural forms have been noted in soil, like plate-like, prismatic, columnar, block-like, spherical and granular. So different types of structural forms or the formation which soil structures take place. Variation in sizes are based on soil aggregates, which are also known as peat. Peat is considered as the unit of soil structure. So whenever we have to study the soil structure, we basically are studying it as a unit, and the unit is peat. Pedology is the study of soil science. So that word basically defines the unit of soil structure. Now soil have peats of different shapes. A well-defined granular structure facilitates aeration and water movement. Water movement and drainage are poor in soils having blocky, prismatic, columnar and platy structures. Whereas if we discuss in detail the plate-like or the platy, they occur in any part of the soil profile or are inherited from the soil material. The prism-like or prismatic, columnar, they occur in subsoil, particularly in the arid and the semi-arid region. Now if we talk of the block-like or the blocky aggregates, they are present in the subsoil, particularly in humid zones. Now let's move on to discuss the soil profile. As we are studying a very important Edaphic Factor Soil, so we have to understand every bit of the basically soil, its formation, its origin, its profile and the various physical and chemical factors which affect the formation of soil. So moving on to the understanding of soil profile. A soil profile is a physical and chemical description of the layers, that is the horizons that make up the soil from the surface to the depth. Now the vertical layers of the soils are formed and are well differentiated from the original parent material. Horizons are labeled according to characteristic properties. Now different layers of soils are formed with time, climatic changes, activities of living organisms and relief. So these different layers which are accumulated one on the top of the other, they are arranged in the form of a horizon. And if we actually say, imagine cut off and we just basically cut a longitudinal section, we'll actually find different layers which are known as horizons. These layers are referred to as O layer, A layer, E, B, C and R, depending upon their position and nature in the soil layer. I will be discussing this. A typical profile of a mature soil includes the following horizons. Now this diagram shows the soil horizons. You can see vertically from top to bottom. When we are moving depth wise, we will see there is zonation. There are different zones or horizons of soil. The top one being the O or the organic layer, which consists of humus which is rich in organic matter, which basically has been formed with decomposition of plants and animals, and it supports the plant growth. Then you can see the second one is the A layer. This zone is A, which is the top soil. It consists of minerals with humus. The third one is the alluviation layer. This is the layer which I talked of when I was discussing about the alluviation process. This layer consists of leached minerals and organic matters, all which has been leached from the top layers, from the O and the A zone. It accumulates in the E zone. So all the leached minerals and organic matter, they are found in this layer. Then below this is the subsoil. What is it? It is basically deposited minerals and other salts which are present. Below this is the parent rock, which is partially weathered, not completely but partially weathered. And lowest is the bedrock. This is basically the underlying unweathered parent rock layer. So you can see big boulders, big rocks which are present in the lowest layer. Now let's discuss all of these layers in detail one by one. Now if I talk of the topmost layer, that is the O layer or the O horizon, which is known as organic layer. It is dominated by organic material, as the name suggests. It includes layer of litter and humus. Now this horizon is not present in cultivated soils, in manicured lawns and severely eroded soils. Why? Because obviously in cultivated soils or manicured lawns, we are all the time changing and we are manipulating the soil structure. So in that case we don't find this top layer, but in nature we definitely found organic or O layer. Then moving on to the next layer, which is A, the mineral soil horizon present at the surface or below an O horizon is referred to as topsoil. It contains a mixture of organic and mineral components. It has more organic carbon. This layer supports plant and microbial growth. So this layer is formed when organic matter gets transformed into humic materials by soil biota. Soil biota means the organisms, the biological organisms present in the soil. So this is very, very important for the growth of plants. The horizon A. Now the humic material coat that the soil particles coloring them brown and black. The formation of this horizon A takes long time, as in decades, and this horizon increases the thickness and the soil organic matter content. Now horizon characterized by alluviation, which I told you is found in E layer, the alluvial layer is found. And how it happens? It happens by the removal of materials such as silicate clay, iron, aluminium, organic matter. It is commonly not found. Usually it is pale colored and low in organic matter. So the texture of it is similar to horizon A, but it has leached materials, that is silicates, etc. Now if we move on to the next horizon, that is horizon B, it is dominated by loss of most of original rock material and shows alluviation, that is concentration of silicate clay, iron, aluminium or humus from the higher zones. Now, these materials get added by leaching from the overlying horizons. So, in the E layer as well as in the B layer, we have most of the accumulated material which has been leached from the upper layers. This zone, the B zone, is formed when dissolved and suspended materials are carried downwards to greater depths with percolating rainwater. It has various sub-horizons which are denoted as BT1, BT2, BTG, etc. So, it has subdivisions or sub-horizons as well. Now, as I told you, soil horizon C is the layer of soil which excludes hard bedrock. Now, it lacks characteristics of O, A or B. So, it has hard rocks present in them. And the soil horizon R is the underlying hard bedrock, the parent rock, from which the rest of the layers have been formed due to weathering, due to mineralization, as I told you, over decades. Now, let's discuss various properties of soil. Now, properties of soil, whether physical or chemical, influence nutrient and water retention required for sustaining the fertility and maintaining productive potential required for the development of plants. Now, let's start with the physical properties. So, first we shall discuss light and heavy soils. Now, the presence of sand, silt or clay imparts a particular texture to the soil, as I already told you. Presence of soil or high silt, particularly clay, gives it a fine texture but show slow water and air movement. Why? Because the particle size is very fine and the water gets stuck in between that. So, these soils become hard because of high water holding capacity. Such soils are called heavy soils because water is more in them. So, clay is known as one of the heavy soils. Now, in contrast, coarse, sandy and gravel soils are called light soils. Why? Because they cannot retain water for longer periods and it gets seeped to the lower layers. So, such soils are called light soils. Now, what are the pore spaces? The pores are the spaces between soil particles or the aggregates. This is also one of the important physical property of the soil that affects the plants growing in them. So, we need to understand the soil pores. So, as I told you that they are the spaces between soil particles or the aggregates. They are important because they allow air and water to move through the soil. They are of different types. Number one, interstitial, small spaces which are present between the soil particles or the aggregates, and the second one are the tubular. Now, these bigger tube-like spaces made by plant, roots or soil animals are the tubular soil pores. Now, pores are generally broken up into two size classes depending upon the size. One will be the macropores and another one will be the micropores. And I think, as the name suggests, you can very well guess that macropores are nothing but the bigger pores that allow free movement of the air and water across. Whereas the micropores, they are the smaller pores, they are the fine pores that help in the movement of air and water only by capillary action. Now, moving on to next physical property of the soil, that's soil color. The color is most useful property for identification of soil. It is determined by the amount of organic matter and iron. Color of soil matrix and mottles indicate water and drainage conditions in the soil. These colors may occur as dominant color, the matrix, or maybe in patches such as mottles. Now, this slide shows the Munsell color chart. In this, you can see that the color of the soil can be quickly determined by comparison of a sample with the standard set of colors chips which are mounted in a notebook called Munsell color chart. Now, this chart basically gives the information about the hue, the chroma and the value. Thus we get the value that what is the exact color of the soil. So this rounded ring like structure tells about the hue. Hue means what color it is of the chroma, like is it blue, is it pink, is it purple, is it whatever color it is, and this is basically the chroma. So chroma gives the intensity of that particular color. So if say the soil falls in blue color, so this chroma tells about what kind of blue, darker blue, lighter blue, or various shades of blue is, we get information about that through this chroma, and thus we get the value of this soil which we are trying to determine the color of. So this is nothing but the Munsell color chart. Now soil color is described by parameters, as I told you, called hue, value and chroma. Hue describes the color spectrum such as yellow, red, blue, green and grey. Chroma indicates the strength of the color. So this slide shows the soil color and the respective properties. You can very well go through this. We can see the rich brown color soil. It's very well aerated and it has pore spaces which are determined by oxygen. Similarly, there are a variety of colors which basically determine the properties of the soil. Now, if we see the black soil, if the color of the soil is black, it indicates the presence of manganese oxides, and if we see the yellow color, it tells us about the presence of hydrated iron oxides and hydroxides. So more yellow color shows the presence of oxides, so it is indicative. The color is indicative of the property of the soil which is present in the soil which is under study. Now next physical property which is very important is soil temperature, that influences the soil property. Now fluctuations in temperature help the physical breaking of rock and mineral grains as well. Lower temperature affects accumulation of organic matter because of low biological activity. Increase in temperature supports chemical weathering. So if the temperature is increasing or decreasing, it affects the formation of soil. Now next is drainage, soil drainage. Now what it indicates? It indicates the status of soil when it is saturated. Saturated means when water is in excess of its field capacity. So excess free water in the root zone can kill plants or pose difficulty in their establishment. So obviously there should not be excess water. So drainage is affected by the soil texture which we just studied. The coarser it is, it tends to drain more rapidly, and the shallow soils tend to drain more rapidly. This property also depends upon the rate of precipitation. The areas with greater rainfall may drain slowly because obviously accumulation will be more than drainage. So precipitation also affects the soil drainage capacity. Now topography also influences the drainage, as the ground level soils drain slowly. Now if there are slopes, obviously drainage will be faster. So moving on to the next physical property, which is the soil consistence. Why we are studying all these physical properties is because they influence ultimately the growth of plant, and we as an edaphic factor tend to understand the soil so that we can very well correlate and understand the ecology of the plants and how they affect each other. So now if we discuss about the soil consistence, soil particles we all know forms aggregate. These aggregate arrange into discrete structural unit called beads. Soil consistence is the property of breaking down of beads. Now it depends upon the soil moisture content. The resistance of soil to deformation or rupture is determined by the cohesive and adhesive properties of the soil. Obviously, for deformation of rupture, if the cohesion and adhesion is higher, then it will be difficult to be ruptured. So this also affects the properties of soil. Coarse textured soils possess large pore spaces that lead to high infiltration, percolation and drainage, while the fine textured soil on the other hand contains small pores and high amount of surface water. Now moving on to the next factor, bulk density. Now, bulk density is the weight of given volume of oven dried soil divided by volume, that is mass of the soil per unit volume of the soil. It is expressed as weight per volume and generally represented in grams per cubic centimeter. Now, the formula to calculate this bulk density is given here in this slide. You can see bulk density can calculated by dividing the mass of the solid by the total volume. Soil bulk density value ranges from 0.5 to 3, but most values are between 0.8 and 1.8. It reflects the amount of pore space in the soil and is an indicator of soil health. High bulk density indicates compacted soils. The plant growth is restricted in these soils. Now, moving on to soil permeability. The rate at which water moves down through the soil is referred to as permeability. It is usually measured in inches per hour, that how much water is moving down through the soil per hour. Pore size, texture, structure, organic content and compaction determine the permeability of a soil. Now, rate or coefficient of permeability is determined by measuring rate of flow of water through a column of soil. The permeability differs for various layers of soil horizon. The property depends upon the pores between the soil particles. Now, soil with high clay content possess low permeability, while sandy soils have high permeability. So, a sandy loam, you can see here in the slide, has a permeability of 2 to 6 inches per hour, while sandy clay loam has a permeability of 0.2 to 0.6 inches per hour. So, it depends upon the type of soil. In an impermeable soil, water is lost through seepage and infiltration. What is infiltration? It is the rate at which the water enters the soil. So, in an impermeable soil, water is lost through seepage and infiltration is thus low. Applying water at rates greater than what soil can take results in ponding. So, this increase in runoff leads to soil erosion and loss of fertility. So, thus, to understand various other factors, we need to understand physical properties of soil. Now, organic matter improves soil structure and improving permeability and infiltration. Now, fine textured soils such as clay contain more total pore space than the coarse textured soil. Water moves more slowly through a fine textured soil, leading to lower permeability and infiltration. Calcium improves soil structure by encouraging the aggregation and increasing the pore size. Now, this increases permeability and infiltration. Microorganisms such as bacteria, fungi, etc., and macroorganisms such as insects and earthworms, which are present in the soil, also increase permeability and infiltration by encouraging the formation of soil aggregates and creating macropores in the soil. Infiltration is influenced by factors such as dryness and slope. Dry soils, they repel water. So, this is true for the soils rich in organic content. Slope may cause water to even run off. Now, moving on to the next parameter, that is water holding capacity. The amount of water the soil can hold against the flow of gravity is also called its field capacity. The maximum amount of water that the soil can hold is called water holding capacity. Now, it is the difference between the amount of water in the soil at the field capacity and the amount of water in the soil at the wilting point which tells about the water holding capacity. So, what is water holding capacity? It is also referred to as available water capacity, AWC, or plant available water, that is PAW. Now, sandy soils, they possess low water holding capacity, whereas the clay soils tend to have a higher water holding capacity. Very high clay content reduces water holding capacity because the tiny pores between the particles, they hold the water very tightly. So what happens is, because of which the clay soils, water holding capacity is reduced. Now in the upcoming lecture I will be discussing about various chemical properties of the soil. Thank you.